core of your IT functions. Again, we manage this and document it and enforce it through service level agreements oftentimes. And so we have service level management being enforced through service level agreements. And of course, that needs to be monitored and managed and enforced by the folks that are outsourcing, which would be IT. Go ahead and do a quick refresh, get my slides proper on the screen. One moment. Back up. So again, the service level agreement is very important, and that's what ISACA we may be testing you about a couple of times. Again, how do we check to manage fulfillment with our service level requirements? We use availability reports is what ISACA prefers. That is what they have on their exam. Software license management also is part of our operations, maintenance, and support. Again, they consider licensing management, software baselines, and software licensing management part of your overall configuration management. Then we also have database management. We talked a little bit about that yesterday. Now we're going to dig into it a little bit more. Database management system. This is what we use to organize, control, use our data. And when reviewing our database administration function, we want to make sure that roles, responsibilities are well defined and that we have proper segregation of duties. ISACA may ask you, within a database management system, what identifies fields, field characteristics, and field usage? And the proper answer to that would be the data dictionary. Other database terms that you need to be familiar with, even if you're not a database administrator, just general ideas that you need to be comfortable with. A record, think about an employee record. An employee record has, well, lots of information. We've got the name, the address, the telephone number. Each one of those items of information are collected together in a record. And if you were to see this on a spreadsheet, you'd probably think of it as, well, a row going across with first name, last name, address, telephone number, and so forth. Each row within that table would be a record. So a record, as you see here, is a collection of related items. Each of those items, I want you to drop down and take a look at, are attributes of that record. So the first name is an attribute, the last name is an attribute, the address is an attribute. The collection of attributes makes that row, makes that record. Now then, another technical name for that row is something called a tuple, T-U-P-L-E. You'll see that there in the middle. That is a row or record in the database. Now then, what's not on this slide, but will be coming up shortly. Remember when I said, you know what, instead of having the full address as an attribute in that record, maybe I can have a reference link from that field off to a central repository where we keep addresses. So I have linked databases now. So I can actually link an attribute to another record in another database. Well, again, the dilemma is if we ever have that connection break because it's referencing a record or a field somewhere else that has been deleted, well, then we have a breach or a break in our referential integrity. Now, why do we need to discuss this again? Because there's another technical term coming. When we have a tuple or a record that is linking to a null value, meaning that linking to information that's been deleted is no longer there, doesn't exist. That is known as a dangling tuple. So when we have a tuple that, again, has had a break in referential integrity and is referring to information that is no longer there, we need to recognize that we now have a referential integrity issue, and we also have a dangling tuple. These are things that will come out in your exam and on the slides coming. So we've got a record, a DBMS, a database management system that manages and controls the database. We have a tuple, which is the same thing as a record, and we know that if a tuple refers to another database field or attribute, and that gets broken, we know we have a referential integrity issue resulting in a dangling tuple. That's right. You don't want your tuples to dangle. That's really embarrassing. So we have an attribute. We have primary key. What is the primary key? Well, think about it. When you want to have some kind of unique identifier for the record. Now, oftentimes, we'll have account numbers, for example. And every record has its own individual unique account number. So if you wanted to be able to uniquely identify a record within that database, one set of attributes or a column of attributes is going to be designated as the primary key for that table, for that database. And so the primary key is that subset of candidate keys within the table that is used to uniquely identify those records. Other database terms you'll need to know about: a view, which is a virtual relation defined by the database to control the subject, which is the requestor of information, from what they can view, which is the object, the data that they're trying to get to. We all experience a view in our real life when, for example, we go to an ATM machine. You go to an ATM machine and you're able to, access your account, input your password, your PIN number. You're able to, work with that database to an extent, but the view that you're seeing, the interface that you're seeing, really controls access, because it's not really giving you access to all of your account information, only a subset of it. And moreover, you're not able to touch your data directly. You're talking to the view, and the view is talking to the database. So it's kind of a middle ground in between you and the actual database. That is a view. I talked earlier about, again, referential integrity. A foreign key, that is the attribute of one database that is linked to the primary key of a record in another database. That's a foreign key relationship. And again, if that gets broken, we have referential integrity issues. So in a database management system, we know that the location of the data and the method of accessing the data are in the directory system. The schema is what holds data that describes the database itself. The data dictionary, we've already talked about before, a repository of data elements and their relationships. Do you need to know really how all of this stuff works together? Not for this exam. But you do need to know these terms and definitions and be able to tell one apart from the other. In your practice questions, typically I do, again, matching on this, so that way you're always able to keep it straight in your mind. Other terms, definitions you'll be tested on: database integrity. Remember I talked about yesterday, we need to support the ACID principle. Remember ACID? Making sure that a transaction either happens in entirety or it doesn't happen at all. And if it breaks down halfway through the processing, we need to roll it back. And we're going to do that by using save points and checkpoints. Now then, if we do complete the transaction in its entirety as ACID prefers, why then we're able to get rid of those save points and checkpoints and say we're willing to commit to this with a commit statement that goes back around and removes the ability to roll back, because we also want to have durability of that transaction. Remember, ACID says once committed to the database, it can't leave. We want to make sure those transactions are recorded and kept. That's ACID. So database integrity, other things that we need to be aware of. Concurrency controls are used to prevent integrity problems when two processes attempt to update the same data at the same time. We only want to have one chef in the kitchen at a time, if you will. So if you're trying to edit your name in your account, we really can't have that field open for editing somewhere else to someone else. So we lock you out, perhaps, of making an editorial change until the other person or the other subject has released that. We also move forward talking about referential integrity. This is, again, where we make sure that we want to have no record referring to the primary key of a record that no longer exists. That would be a null value. That would be a breach of referential integrity. So how do we make sure that we have good database integrity? Why we do table links and reference checks. Again, we need to review our foreign keys, because that's the relationship of one field in this database linking to the primary key of a record in another database. in order to evaluate that referential integrity. And then, of course, you've got some bold-faced italicized points that kind of give you an exam-y feel for what you need to know about these things for your test. Okay, so moving along, normalization. Remember when I said it doesn't make a lot of sense to have redundant data in multiple databases all over the place? If I'm going to have an address of somebody in one database and the address of somebody in another database and the same address of that person in another database, why should I have 3 copies of it that could end up not matching over time? Why don't I just have 1 copy of the address and each of those 3 databases point to it when they need to show the address? This is a way that we can normalize our databases. And what it also does is it condenses the size of the database necessary because you don't have all of that bulk of redundant data in there. Now, ISACA may ask you, well, what happens when you denormalize a database? Well, that's basically saying I don't want to have all of these handy linked relationships. I want to actually have the full copy of the full data everywhere. Well, gosh, can you imagine? What if the data wasn't just an address? What if the data was a 30-page contract that is referred to multiple times in different databases? Would you really want to have that full 30-page document as data in each of those databases? If we denormalize, that's what we've done. And of course, that increases unnecessary redundancy of data. Capacity management. We move forward. Again, we want to make sure that we have our resources fit for purpose. So we need to make sure that we use capacity monitoring software to ensure that we can continue efficient operations. This is a type of performance monitoring. ISACA feels that you begin your performance monitoring by looking at your network topology diagrams. You may have different feels on this, but again, take a look at this statement very carefully. When assessing the design of network monitoring controls, RTFQ, they didn't say your IT as a whole, they say network monitoring controls. Well, when it comes to network monitoring, we need to look at, well, what is the architecture of our network anyway? Those are our topology diagrams. So again, more exam-y terms and definitions that we need to know related to this concept would include your graphical interface to map the network topology, which is also sometimes in other questions called a network diagram, and in other questions, the very same thing could be called a wiring and schematic diagram. Same question, different answers that different people get. Those are the 3 different ways they may call it. Network performance monitoring tools, what do they primarily affect? Confidentiality? Not so much. Integrity? Not so much. Performance monitoring really goes to network availability. Tools and reports, again, they're going to ask you perhaps, how would you measure network performance in terms of transmission latency? If you're not a network person, then you go, what do you mean latency? Don't worry about it. If you were worried about latency, you would use a ping command and look at what comes back from it to determine how long it's taking for packets to get from your machine to someone else. It's a diagnostic command that we run from a command prompt. We typically not only get latency information, but a lot of it is just to determine whether or not we can reach the other side, if you will. So change, configuration, release management. Again, we know that from yesterday, ISACA does hate default configurations. And so we understand then that configuration management is accepted as one of the most critical components in networking management. Remember, ISACA hates default configurations, and accordingly, they want to make sure that you disable vendor default accounts and so on. Again, with security patches, you need to assess the impact of a patch prior to installation, not after installation. IT people know all about this. Again, change, configuration, and release management. You'll see that I do have a hyperlink in the downloadable presentation that goes off to an outside resource. You don't need to know everything in that external resource. It's just there for your general information and convenience if you feel like it. What do you need to know for the tests? You need to know these things that are on this slide. Change management procedures established by IS management to control the movement of applications from the test environment to the production environment. That is a change management function. Patch management is helpful to prevent exploitation of system vulnerabilities. That same question comes out in your C-risk exam as well. Change control security procedures. We, again, look at poor change management. ISACA is a freak for ensuring that we have authorized changes. Remember, I told you about that. They are not so concerned about a bad change as they are an unauthorized change. An authorized bad change is actually okay in ISACA's world, because it isn't our job as an auditor to measure the elegance or of a change. It's our job to make sure, number one, that it was authorized, and then number two, that it didn't break anything. So we're going to go ahead and move forward then. Change control security procedures. When migrating an application program from the test environment to the production environment, the best practice is to have the production control group copying the source program to the production libraries and then compiling it. That is, again, separating systems and application development from the end users, creating that safe zone in the middle. Again, change control security procedures. Again, ISACA may ask you, what would you look at in order to detect if a programmer maliciously modified a production program? Well, you would look at, the proper answer in ISACA's world is the system log files, because that records the activity that was performed on the database. So, or the application rather. So if an IS auditor discovers modifications been made to a source code, again, what should you do? Should you freak out? Should you go ahead and sequester that into the application? It says, well, first, before you freak out about anything, what does ISACA care about mostly? Were the changes authorized? Were the modifications authorized? So before you do anything with it, first make sure that the changes were authorized. Then look to other issues. The purpose of code signing, this is where we actually are able to use a type of hashing along with encryption with public-private keys in order to uniquely sign or authenticate the integrity and the source of an actual executable file. So code signing, this process, makes sure that we can easily detect if software has been modified since it was last signed. So for example, the very executables that your system uses to run Microsoft Word and Outlook and other things, Microsoft issues final signatures to the vendors of McAfee and Norton and so on. So that way, McAfee, Norton, and other antivirus systems can actually look through and see the executable files that run your applications and see if, hey, if we independently calculate what a signature should look like using the same math algorithms, would it match up to what Microsoft told us it should look like? And if that doesn't match, then we know that perhaps that source code has been modified since Microsoft released it, and that could signify a virus. So this is what code signing is all about. This is how it's used. Again, library control software, again, is where we're segregating production from development. Again, making sure that even the folks in library in the central library between the two can't turn into developers and start to code themselves. That's why when the code is released to the library, it is released in read-only format. Auditing system software. We have a fancy way of saying, look at how your systems are configured. That's right. We shall review the system generation parameters. What? Yeah. How your system is set up, how it's configured. We'll review that as a way to determine what controls are functioning properly within an operating system. An auditor performing an operating systems audit would review operating systems parameter settings, meaning the configuration, to verify what controls are in place. Again, auditing system software, I won't read to you every single one of these items. These are things that you just need to memorize for your exam as it relates to the points that ISACA wants you to know relating to auditing of system software. Now then, yes, we need to know a little bit about systems operating states, because it turns out that this is where security compromises can happen way down at the application and systems and really the underlying computer architecture level. So when the system and the system processing is run by something known as a kernel, not with a C-O-L, but rather with a K-E-R-N-A-L, kernel. The kernel is the heart of the hardware that processes executables. Now, here's the thing. That thing needs to, again, how it manages and how it runs and executes threads of a process needs to be controlled and needs to be watched and needs to be managed. You're going to need to know enough about that to be able to know the difference between a ready state, a supervisory state, a problem state, and a wait state. So think about the processor, the kernel that's doing all the work of processing things. If it's in a ready state, it says, hey, look, I'm hanging out. I'm ready to work on something. Bring it. That is ready to resume processing. That's in a ready state. Let me skip forward to problem state. If it's working on a problem, in other words, if it's working on execution, it's doing something, then that is said to be in a problem state. Not a problem as in there's something we need to fix, but rather it's working on a problem is the best way I can help you remember it. So if I'm not doing anything, I'm in a ready state. If I'm in a problem state, I'm working on something. And when I get done, I'll go back to being in a ready state. Okay, what about a wait state? Well, what happens if I need to work on something, but it turns out now I need some other execution to happen and give me answers back before I can continue working on something? That means I can be, well, not in a ready state, but I'm also not working on anything because I'm waiting on something else to complete. That's called a wait state. An example of when you see a wait state is when a wait state actually gets hung up. You're not supposed to see it as a person, but it can happen. If you've ever had, for example, a common one, for me at least, is I'll have Outlook where I'll go ahead and try to start Outlook, and I'll see it spin the wheel and try, and then Outlook doesn't come up. And I click it again, and I'll see the wheel spinning, and it's trying, and Outlook doesn't come up. If you actually go into your task manager, Control-Alt-Delete on a Windows machine, and go through processes, you'll see where Outlook.exe is running. But why is it running? I don't see it running. It won't come up. Turns out it's in a wait state. It's waiting for something else to execute. What? I don't know. But if I go ahead and kill that process that's in a wait state and then try to restart Outlook, it opens. So again, this is where you can have issues where things get stuck in a wait state. Now then, you now know the relationship of ready state versus problem state versus wait state. What about that supervisory state? That is a type of problem state, but for privileged process execution. Like what privilege? Like, well, managing memory, for example, or managing access between system configurations and things like this. So supervisory state is a type of problem state, but we're executing a very privileged system process, and therefore it needs to be isolated and protected from other processes. Supervisory state. What do you need to know for your exam? The difference between those terms. Network resiliency, yeah, they may even reference the old leased ATM lines that we talked about, asynchronous transfer mode lines, where we had ATM network connections. I remember teaching Cisco and actually teaching how to set up ATM connections way back in 2001, I guess it was. But again, all of these things I won't read to you because they're just simple things that you need to memorize for your network resiliency questions. So this is going to lead us into getting into business resilience topics. Let me go ahead and check something out. One moment. Need to pull something up on my side. Okay, very good. Just had to check out my timing, make sure that I'm okay and on track, and I am. Very good. So let's go ahead and move forward then with business resilience topics. Again, there was a time when it had its own domain, but now it actually is combined. Business continuity, disaster recovery. What about our plan initiation? First off, how do you start this process? Continuity planning is the process of making plans that ensure critical business functions can withstand a variety of emergencies. And so related questions. What is business continuity? Enabling the business to continue to offer critical service in the event of a disruption. That is a definition. The goal is to reduce business risk by reducing disruption risk, right? The primary responsibility of BCP, of business continuity planning, lies with senior management. What do they mean by that? Well, think about it. If I'm the head of department for some operations department, or maybe even procurement, we'll say, who is ultimately accountable for making sure that my department runs successfully and well? The department head. Consequently, the department head is the chief risk officer for their own department. And guess what? Business continuity disaster recovery is just another flavor of managing risk. It's managing disruption risk, right? Availability risk. So this is why the true role responsibility is accountable to the head of department, the one that owns the success or failure of that department. That's senior management. Disaster recovery planning. This is making preparations for a disaster, addressing procedures to be followed during, after a loss. How to survive from a disastrous event, right? Now then, see the second bullet. This is old thinking, but may still persist on your exam. There was a time when we talked about disaster recovery planning, we were typically talking about systems crashing and losing all of our data. And so I remember back in 2005, if we contacted an organization to talk about helping them with their disaster recovery, they would automatically forward us to the IT people because they handle DRP. Well, disaster recovery planning isn't just about the IT aspect. It's also about getting your people out of the building, perhaps. It's about making sure your customers don't leave you for a competitor while you're trying to get things going again. There's a lot of stuff involved with disaster recovery that's beyond IT. But way back in the day, we looked at disaster recovery as being a subset of business continuity planning. Weird, but true. That concept, by the way, was originally born from the Disaster Recovery Institute International. I know because I used to teach out of their manuals once upon a time, 20 years ago. So, financial justification for continuity planning. Again, the idea is that we'll spend more upfront to decrease the duration and impact of a disruption when it happens. So in other words, we're spending more now and hoping to save that and more later by being better prepared. So this also means there could be a tricky question here. After implementing a disaster recovery plan, what happens to your pre-disaster and post-disaster operational costs? Both will actually increase because, well, if you had no plans, it doesn't cost to maintain no plans. So that's cheaper. And if a disaster happens and you don't have any kind of way or system or process set up to recover from it, well, you're not going to do anything. Your organization just crashes. So that means your operating costs, because RTFQ, they're going to ask about your operating costs. Your operating costs pre and post disaster increase because you're doing more. Now, of course, the opportunity cost is not what they're asking about. Not preparing for disaster and not responding to one ultimately could kill the business, which is more expensive than anything. But they're not asking about that, are they? They're asking about operating costs. So be careful. Implementing disaster recovery plans tends to increase